right, everyone, welcome back. Found a classroom I could use on campus, so why not? Anyways, so last time we were talking about products of trigonometric intervals, right? So we never really actually got into some examples of it, so that's what I'm going to do now, is we are just going to do a cool little integral, and like I usually am, I'm going to be very thorough with it, but I will tell you some shortcuts right from the start. And what's really cool about the Euler notation is that I only got this insight once I actually did these integrals this way, which is the following. So let's just talk about some integral we'll call cosine of, I don't know, 7x, and then sine of, let's go with 3x. Okay, so if you're not using Euler's notation, I think the way you solve these integrals is you break 7x into a product, sorry, not into a product, into a sum, and then use your sum identity, same with sine, and you go through all those integrals. But we are going to be using Euler's identity, which if I walk over here, I'll just have it over to the side right now, we will say that, and this wire might get in the way, that's my microphone wire. I don't have a wireless because I'm bored. All right, so we have sine of, x being equal to e to the ix minus e to the negative ix all over 2i. And then we have cosine of x, which is equal to e to the ix plus e to the negative ix all over 2. Okay. So we remember those and we love those. Okay, so quickly before we actually dive into, first off, putting these notations in their correct form, multiplying it out, because you know it's multiplication, so we'll get a, what we call in America, FOIL, and then we'll integrate those individually and finally get it out. But one thing, the insight and the shortcut you should realize, and it's not really quite a shortcut, but it is a shortcut in some way. What you will notice when doing these kind of integrals is that you'll always get an answer in which there is the difference of your arguments, and then there is going to be a sum of your arguments. In other words, you'll always get something, and remember, and now this is even the cooler part, it'll always be cosine of them. So for example, I know right off the bat, without even doing any math, that this will have an argument that's either, like this, and I'll have a k out front for the whatever constant we find it to be, plus another constant of cosine of 10x. And you may ask yourself, why? And it's hidden in Euler's identity, right? Because remember, cosine picks up that imaginary constant, right? Picks up the imaginary part. But we know this has a real valued answer, right? So we know at the end of the day, our answer is only going to involve cosines, right? And this will be something you'll see as you actually do the problem, is that if you don't have your, so for example, once we do our substitutions and all that, you should notice in the algebra that you should have a negative kx plus another positive kx. I apologize for this. And the reason for this is because we need these to cancel out the sine component, right? Because if the sine component doesn't cancel out, you made a mistake, right? Because you know the answer to this is real. It's not imaginary. So we should not be picking up any imaginary parts. And 1 second, let me get a microphone, let me get an eraser real fast. I've got to bring it over. And now let me pick this back up. Great. Okay, so now let's go ahead and put this in our notation, right? So we know wherever we see this, we're just going to put our 7 there. So we know this is equal to the integral of e to the I, sorry, let's just make this better, e to the 7ix minus, sorry, plus e to the negative 7ix all over 2. times this one, which is 3. So this is going to be times e to the 3ix minus e to the negative 3ix all over 2I. Okay. So then now, we just have to slug through the computations, and then you'll see the inside pop out, which is very cool. This is why I love this method so much for this product of cosines and sines, right? Because it makes it very intuitive. And like I said before, I never noticed this pattern until I started doing it this way. But let's just chug through it anyways. Okay. And then, like I said, the reason why I put plus here is because this constant could be negative, this could be negative. The negative is thrown into the constant for now in my abstract notation. Anyways, let me flip over here and let's actually just do it. So we're gonna get e to the 7ix, and then, oh, by the way, because you notice how both of these have a 2 and a 2i, so I'm just gonna put this over here, 1 over 4i, and I'll worry about it later, okay? So, we now know that we can just distribute. So we're gonna do e to the 7ix times e to the 3ix, which is e to the 10ix. Whoa, remember that 10x is right there, it's kind of trippy, right? E to the 7ix times negative e to the negative 3x is gonna be minus e to the 4ix. What did you know? It says a 4 there. So you see where these come from. And that's why you will always know when you're doing a problem like this, your answer will always involve the difference of the two and the sum of the two, right? And then we'll go ahead, as we go through this, you'll see what I talked about earlier. You should always have e to the ikx in one minus plus e to the negative ikx in the other. And we'll see why in a second. Or minus, I forget. We'll just go through it. Okay, so let's keep going. So we did this one, now we'll do this one. So we have e to the negative 7ix plus times e to the 3ix, which is plus e to the negative 4ix, which is good. And then, because this is negative and this is positive, right? So we know right off the bat, these will probably cancel out, which is good. And then we have e to the 7ix times e to the negative 3ix, and this is going to be a minus e to the negative 10ix. And then, oops, I forgot. We're all doing integral, so I should be complete and put a dx here. Great. Okay. So all we have to do now is chug through these computations, right? So to make our lives easy, we can actually, let's not even color code it. Let's just, because I don't want to run this board, so I'm just gonna keep it in white the whole time. Now that I think about it. Okay, so here we'll do u equals 10ix. Let's just put this here. So then du is equal to what? 10I dx, right? So if we go ahead and chug through this, remember, we're going to multiply it by I on both sides. So we get I du equals negative 10 dx, or in other words, I over 10 du equal to dx for this one, right? And then I will erase this above it so we can just put our results up here. Actually, I'll erase this over here because we have a lot more space that we could be using. Okay, so that's done. Okay, so over here, we're going to start writing up all the terms, right? So over here, we have a 1 over 4i times. Okay, so we're just going to do these integrals one by one. So this is going to be e to the u, which is e to the u if I integrate it, times I over 10, right? And it's negative. You see, I almost forgot to write that negative right here. So remember, write your negatives. Because it's negative 10 over here, we're dividing by negative 10, so this is a negative quantity. So this integral right here is negative I over 10 e to the 10 ix. Great. Now, over here, we're going to say u, and actually we can erase this one now, so see ya. Okay, so we're on this one now. Okay, and make sure you keep this negative here because it might matter. Okay, so over here we'll say, okay, u is equal to 4ix. Then du is, of course, 4I dx. Multiply by I again, we get I du is equal to negative 4 dx, because I squared is negative 1. Then over here we get negative I over 4 du is equal to dx. So this is negative, so keep that in mind. So when I put it up here, this is negative, this is negative. Guess what happens? We add them up. So this one over here becomes plus I over 4 e to the 4 ix. So now you can erase this guy. Okay, great. Now we're on this one. Go through it again. U is equal to negative 4 ix. And keep in mind, this is negative now. So when I say du is equal to negative 4I dx, we're going to go ahead and pre-multiply by that I per usual. We're going to get I du is equal to positive 4 dx now, right? So at the final one, we don't have a negative anymore. This is positive. So we're going to have I du over 4 is equal to dx. Whoa, so now when we substitute this one back up here, you'll notice something pretty cool. We had a plus I over 4 e to the negative 4 ix. So what we should realize is that this and this are pretty much the same thing, but they only differ by a factor of negative in the exponent, which is good. All right, so now finally we have this last one, which is e to the negative 10ix, right? So keep in mind we have this negative here, so this is going to be u is equal to negative 10 ix. Du is equal to negative 10 I dx. Pre-multiply by the I per usual. We're going to get I du is equal to positive 10 dx, right? Because I squared is negative 1 multiplied by negative becomes positive. So this one over here, we don't get to cancel out this negative, right? We don't get to cancel it out. So what do we get is I over 10 du is equal to dx. So then finally, this negative stays here, and we get minus I over 10 e to the negative 10 ix, right? And now you may panic for a second. Plus c, okay. You may panic for a second, right? You might be like, okay, Ramin, that thing you told me earlier is not turning out to be true. But it is, right? Because you notice this is a negative and this is a negative, just factor it out. And so here's the insight you'll have now. Because you notice how these are both negative, now I know that the quantity involving this one, this k can stay here. We know it's going to be something like this now. Just, that's all it is. All it is now we can just factor out a negative one of those, and we'll be fine. Okay, so let's finish up this integral. So, once again, the shortcut you'll notice is because we're differing by the same coefficients in our exponents, that we're going to pick up two of these cosines and their signs are going to cancel out. We're going to pick up two of these cosines and their signs are going to cancel out. But I'm going to be thorough and walk you through the whole thing, right? And then another little shortcut is, you notice how we all have I. Look at this bad boy. We have 1 over 4i here. So we can go ahead and take this out, take this out, take this out, take this out, and take this out. So we're going to have 1, 1, 1, 1. Beautiful, right? That takes away that imaginary component. All right. So just to be thorough, I'll walk us through all of it. So this first one, we have and I'll keep this 1/4 out here. This first one, we have -1/10. And actually, just to make our life easier, I'm going to actually factor these together and factor these together, okay? And then I'm gonna multiply by the 1/4. So you'll watch what I'm gonna do right here. So I'm gonna take out this -1/10 right here. And in here I have e to the 10ix plus e to the -10ix. And over here I have plus 1/4 e to the 4ix plus e to the -4ix. Okay, so once again, to make our life easier, I'm gonna multiply, I'm gonna distribute this 1/4 to all of these. So over here becomes 1/40, and over here becomes 1/16. Okay, great. So now all we have to do is just chug these out. Well, remember, this is simply just I sine of 10x plus cosine of 10x plus negative I sine of 10x plus cosine of 10x. And no, this is not a matrix. Sorry for my crappy notation and my bad handwriting. This is not a matrix. But what you will notice is I have a negative I sine x 10x here and a I sine 10x here. These just go away. And those add up together. So now I have 1/40 times 2 cosine of 10x. And the same thing's gonna happen over here. I have plus 1/16 times, and this one I'll write up all the way. We have I sine of 4x plus cosine of 4x. So let me switch over here. Minus I sine of 4x plus cosine of 4x. So remember, and I didn't talk about over here, but I'll talk about here real fast. Remember, because sine is an odd function, when I input this sine of -4x, remember, odd functions have the property that you can take this negative and throw it on the outside. That's all. So that's why this is a minus and this is a plus, right? It's just because of that property, odd functions. And that's why cosine is positive, because cosine is an even function. So it eats up the negative. Okay, so whoa, what do we notice once again? Cancel, cancel, like it should. So then we add these together, and we get 2 cosine of 4x. Just as predicted. Just as predicted. So finally, we're not done yet because we still have to distribute our coefficients. And I almost made a great mistake. This technically was -1/10. So I should have put a negative right there. Close call, close call. Okay, so finally, let's finish up. So over here, we get 2/40, which is negative cosine over 20. And then over here, we get 2/16, which is cosine of 4x over 8. So finally, just as predicted, and I shouldn't have used k twice. That's my laziness. So up here, this is gonna be minus, and up here, this will be over 8. And then of course, plus. All right, and there you go. Hopefully that gave you some insight. Like I said, as you get better with this notation, you'll see the shortcuts like I mentioned. I do hope you do go through it thoroughly, like once or twice on your own, just so you can get like a better intuition for the steps. But outside of that, hopefully this really helped. Good luck.